Hello class 11th. In the last lecture we have discussed about the frame of reference, point mass, the rest motion, speed and velocity. After these topics I have some queries. So I am starting to clear that I am starting the doubts first. So first topic, first doubt that I got from your side, that is, what is kinematics? Explain again. So if you remember, I said this is any object, this is moving from here to here with some velocity, let's say 5 meters per second. So this object is this object is getting speed, and if some object is moving with some velocity, it means what? Some agent must be there. So I'm not talking about the agent. If you will not talk about the agent who is pushing or who is retarding, I'm just only talking about their motion. I'm just talking about only their motion. What is the initial position? What is the final position? With what velocity it is moving? What is initial velocity? What is final velocity? Except these, we will not talk about the force. Who was the agent to push this, or who was the agent to give this velocity, or give this energy, or give this movement. So only we will talk about the motion, initial, final and blah blah. If you are not talking about the force, the external agent, then you are studying about what? The kinematics. Next point that I got in the doubt section, that what is frame of reference? Very easy. Frame of reference means from where you are observing. You might have the photo frame at your home. So suppose in that photo frame you are alive. So and you are putting that photo frame just inside the showcase. So from where that photo is observing you? From the showcase. Just put that photo frame above the almirah. From where that photo is observing you? Above the almirah. So that is different frame of reference. Same way, let's understand this. You are sitting in a car here. If you are sitting in this car, and in the car, for you and the car, both are at rest initially. I am talking about initially, both of them are in rest. At that time, for you, what is the position of car? For that time in this car, what is the position, means coordinates? If I am talking about the 3 dimension, so you will say the origin, the car is at origin. So at this time the coordinates are 0, 0, 0. This car is moving in this direction right now. Here is the new position. But for you, the car is with you, means the car is still in rest. What is the coordinates will be here for you? You are observing the car inside by sitting inside. Here again you are inside the car. What will be the coordinates for you? Again 0, 0, 0. So this is what? The frame of reference. The relative velocity between you and the car is 0. That is why you are feeling that the car is in rest. And you have the same frame of reference. You can say inertial frame of reference. This is what? Inertial frame of reference. What is the common in the inertial frame of reference? If it is inertial frame of reference, so there will not be any external force. So as we know that F is equal to ma. As F is equal to 0, so ma is equal to 0. But m cannot be ever 0. What will be 0 then? A will be 0. So here you can say there is no acceleration from here to here. If there is no acceleration in the positioning when you are inside the car here and here, there is no change in position of the car. 0 and 0 always, the coordinates. So what you will say, there is no change in position, means according to your frame of reference, the car is in rest, having the coordinates 0, 0, 0. But suppose now you are observing from here, from the middle, and for you from the middle this distance is minus x because it's from the left, and this distance is positive x. So from here, means if you are observing from this frame of reference, means outside the car, from this frame of reference, you will say that this car is at distance minus x and this position is right now is having plus x. What is changed? The position is changed. Why? Because you are observing now from different frame of reference. Here it was inertial frame of reference, and here you can say if the velocity is increasing. Suppose here initial velocity was 0 and after the starting of the car is moving with some acceleration and arrived here from 0 meter per second to now 5 meter per second. So here is what? Acceleration. So if you are observing from outside and the car is moving with some increasing velocity, with some acceleration, so there is a force, because F is equal to ma is not 0, and because F is equal to ma is not 0 now, so there is some force. So if there is external force, then you will say this is non-inertial frame. Again example, suppose these the two objects, I am showing you my hand, this hand and this hand, both are moving together. For them, they are in rest, because this is one type of frame of reference. And now suppose this is in rest and this one is moving, then what? This is different frame of reference. Another example, you are observing this tree sitting on earth. Suppose I am observing this tree. So what I will see here, the tree is in rest, no external force, no acceleration. So this frame of reference means I am observing this tree in sitting inertial frame of reference. Now suppose I am outside the earth and observing this tree. What will happen? The tree will be moving. So this is different frame of reference. Same tree observed from different places has different motion. So that this is called frame of reference, from where you are observing. If there is no acceleration, no external force, then you will say this is inertial frame of reference. And if any object is accelerating, then you will say that is non-inertial frame of reference. If you are still facing any problem, inform me again. I will use some different example. Now the next topic, before going to the next topic, I want to show you about the last topic where we ended. The velocity where we ended. The velocity is what? The change in displacement upon change in time. If the time is so small, so velocity is equal to limit delta t tending to 0 del s upon del t. And instead of writing this in this form, we will use which form? Calculus method. So v is equal to limit delta s tending to 0 del s upon del t. Now using the calculus method, this v will be equal to ds upon dt. So if the time is very small, then you will use this method. This is called calculus method. And those who are studying the mathematics, in this they have the mathematics for them. This will be in their syllabus from where it is coming. But those who are not opting the mathematics, they have to learn. The Puneet sir will help you how to understand this. In the first chapter, in the starting chapters, these are there. But at this time, just remember that v is equal to what? ds upon dt. Same way, I am talking about the acceleration. What is acceleration? The rate of change of velocity. Suppose I am showing you the 3 points. Point A, B, C. In these 3 points, suppose at A, the velocity was 0 meter per second. At B, velocity 5 meter per second. At C, velocity 10 meter per second. And duration from A to B and B to C
1 second
is of 1 second. So what is the change in velocity from A to B? 0 to 5, that is change of 5 meter per second. And in how much time? In 1 second. So the rate of change of velocity. Change in velocity, the unit time is what? Acceleration. So what is the change in velocity? 5 meter per second. In how much time? In 1 second. So 5 meter per second divided by 1 second gives 5 meter per second square. This is what? Acceleration. Same way in the next B to C, there is also change of 5 meter per second in 1 second. So acceleration will be 5 meter per second. So rate of change of velocity is acceleration. Here the acceleration from A to B is 5 meter per second. From B to C again 5 meter per second. So what you will write? the v is equal to the acceleration is equal to del v upon del t. That is what? The rate of change of velocity. If the time is very small, so a is equal to limit delta t tending to 0 del v upon del t. Instead of this writing in the calculus method, what we will write? A is equal to ds upon, sorry, A is equal to dv upon dt. A is equal to dv upon dt. And if you remember, what was v? V was equal to ds upon dt. Just place that instead of v. So on writing ds upon dt in place of v, we will get acceleration is equal to dv upon dt is equal to d2s upon dt square. So this is all about acceleration. If you are still not understanding, just see in the sheets. So see here the acceleration. I have taken again the same positions at A, B, C, 0 meter per second, 5 meter per second, 10 meter per second, and duration is of 1 second. So let's calculate the change in velocity. That is 5 meter per second minus 0 meter per second, change from A to B. So this is the change in velocity, and the change in time from A to B is 1 second. According to the definition, acceleration is equal to rate of change of velocity means change in velocity in a unit time. Let's write that. So you can see change in velocity in a unit time. So velocity change has 5 meter per second, and the change in time is of 1 second. On dividing this, it becomes 5, and meter per second divided by second makes meter per second square. So acceleration is there 5 meter per second square. You can calculate of any motion. From here to here it is 5, here 5 to 10 it is still 5 meter per second. Now again see another scenario. In this scenario you can see at A 5 meter per second, B 5 meter per second, C 5 meter per second, means all the positions the velocity remains same and the duration is still of 1 second. Now let's calculate the change in velocity. So what we have got, change in velocity here 0 meter per second and change in time 1 second. So the acceleration del v upon del t, so whatever the change in velocity, that is 0 meter per second, and time is 1 second, 2 second, whatever you can take. So here what you got, acceleration 0. So acceleration 0 it doesn't mean acceleration 0, it doesn't mean that object is in rest. Acceleration 0 means the object is moving with constant velocity. So acceleration 0, it doesn't mean that object will be in rest always. Here see, the object is in motion, object is moving with constant velocity. So if acceleration is 0, it means either the object is in rest or it is moving with constant velocity like this. So let's see the expression now. This is the expression for acceleration. You might have seen in the class 9th. And this time, if this time is very small, very fine value is there, then what we will write? Limit delta t tending to 0 del v upon del t. So after this, what we will write in the calculus method form? So the A is equal to dv upon dt. And if you know that, since in the last video v was equal to ds upon dt in the calculus method form, so just put the value of v here. So see here, acceleration is equal to dv upon dt is equal to d by dt. I have just taken it separate. In place of v, I have written ds upon dt. Now open the bracket, what you will see, the d2s upon dt square. This is also this how to pronunciate this. Don't say that d square t square. You have to see d2s upon dt square. This is the acceleration equation, that dv upon dt or d2s upon dt square. These two expressions will be helpful to you. The next topic is displacement time graph. If you are measuring, if you are plotting the time on the x-axis and displacement on the y-axis of any moving object, so the graph will be called displacement time graph. And using that graph, what we can calculate different quantities, physical quantities. Let's see. So here I am starting a new topic, displacement time graph. First of all, I am going to draw how many possible graphs that you can see in the book. So first possibility, that it will be a straight line in this direction. Second, horizontal to the time axis. Third, declining to the time. Or the last, in that the graph will be in the form of curve like this or like this or any form. So first of all, I am starting with this graph. So here I am taking the first graph displacement time graph where the graph is increasing linearly. So here what we can calculate, we have the two options to calculate for every graph. Means here I am giving the information about displacement time graph. In any type of graph you can calculate the two things. First, the slope of the graph, and second, the area of the graph, and see what we can calculate. So to calculate the slope of the graph, let's see, suppose this point, I know this is 0, but I'm considering this initial point is having the displacement s1, and after some time, see here, after some time, say this is s2, here s1, here s2, after time how much, that this is from here to here, the total time taken t, after t time, this is the displacement. So what I said, what we can calculate, the slope and the area. First of all, I'm going to calculate the slope of the graph. So I have named the graph OA and I have written slope of the graph OA. So what is slope? So first of all, so slope of the graph means change on y-axis divided by change on x-axis. So you can write also that delta y upon delta x, if you are saying that this is y-axis and this is x-axis. So change in y upon change in x. What is the change in y? See, s2 minus s1. So you can write s2 minus s1. And change in x, t minus 0. T minus 0. So here the subtraction of two value of displacement will something will, what will you will get? Still displacement you will get here. Suppose this is s2 minus s1 be s, and the t minus 0 is t. What is the unit of s? This is in meter. And what is the unit of time? Is it in second? So which physical quantity you are getting? That is meter per second, na? So which physical quantity is meter per second? That is velocity. So this is what? The velocity. So what we have got? We have got this, the slope of displacement time graph gives velocity. See here. Why? The change in displacement will give the value in meter, change in time will give the value in second, total becomes meter per second. So slope of the graph will be what? Slope of the displacement time graph gives velocity. So if suppose in examination it is asked to calculate the velocity of this displacement time graph, so what you will calculate? The slope you will calculate, and then you will get what? The velocity. If you are calculating slope, you will calculate what? Velocity. Now the second thing is area of the graph. So area, suppose this is point O, this is point A, this is B. So this is just like a triangle. So what we can calculate? The area of triangle OAB. Let's calculate here. So here area of triangle OAB is equal to half into base into height. Base into height. Let's fill the value. Half into value of OB. This is the time T. Value of AB S2 minus S1. This can be at t minus 0. So again half into time into displacement. So let's write the unit. Unit of time is second and unit of displacement is meter. So it becomes what? Meter second. There is no physical quantity which has unit meter per second, meter second. So on calculating area of displacement time graph, remember this, area of, so on calculating the area of displacement time graph, no physical quantity is obtained. Means in examination the question will never ask about the area of this displacement time graph. It may ask for the other graphs. So what we have calculated from displacement time graph, slope of graph is equal to velocity of the body and area of the graph is nothing. So now see the next graph. See the different type of graph. When the displacement time graph is horizontal to the time axis, again same thing. If you will calculate area means say this is like a rectangle, length into breadth, meter into second, no physical quantity. On calculating what? The slope, we can calculate something, that is what? Velocity. So I'm going to calculate velocity of this graph. So see here, slope means velocity, means S2 minus S1, two positions of displacement and two position of times. So you can see there is no change in displacement. S2 is S, whatever you can calculate, or whatever you will say, whatever it is S2, same is S1 also, means S2 minus S1 here will give 0 value. It will give 0 value, and change in time, there is something time, means suppose t time is calculated from 0 to this, sorry, O to C, t is calculated. So what you will get? 0. It means if the person is having velocity 0, and you can see here also displacement is 0, means the person is not moving right now. Now see the another type of graph when the graph is declining toward the time axis from A to B. Again, what we can calculate? Slope only. Let's calculate. So see here. So let's fill the values. S2 means final position. What is final position? You can see final displacement is 0. Final y-axis final displacement is 0 minus what is initial displacement? Suppose this is point S. I'm giving the value of S1 as S upon final time. Suppose T, initial time 0. What you have got? Minus S upon T, means the value of velocity will be minus S upon T, means negative value. See, the slope is declining, so the value of V will be negative. As we know that velocity is a vector quantity, it can be positive, 0 and negative as well. So this is the possible graphs. So in the next lecture we will discuss about the velocity time graph, but remember what you have to calculate in for every graph. One thing, slope you will calculate, and second thing, area. Okay, remember this. Only two things we will calculate, slope and area. In this displacement time graph, on calculating slope you will get velocity of the body, on calculating graph you will get nothing. Okay, now see one example, that is a boy reached a railway station 4 km away from his house. So see, 4 km away from his house. Suppose this is the railway station. Now running with the uniform speed in 1 hour. So you can see here from O to A, it is half an hour, it is 1 hour. In 1 hour it is reaching to the railway station at A. He took rest of 0.5 hour at this station and then came back to his house. So see here, this is the 0.5 hour he is taking rest at the station, and then he back to by walking with the uniform speed 1.5 hour. So from B to here, see here 1.5 hour and then 1.5 hour. So take total time 3 hour. Represent the whole journey of the boy by time displacement graph. So you have to draw this graph in this way. Half an hour, then half an hour, means it is taking total 1 hour. 1 hour up to reaching the railway station. Then next half an hour taking rest, means no displacement. Here you can see the displacement, and then no displacement. And from B to C it is returning back, so displacement will be 0. So it is returning, so graph will come down. So it is here right now. So this is here. In how much time? Next 1.5 hour. So 1.5 plus 1.5 makes 3 hour. Now calculate his average speed. So average speed is total distance upon total time. What is total distance? 4 km in up and 4 km down. Total distance 8 km and total time 3 hour. So it becomes 8 by 3 km per hour. This is average speed. But if suppose in the question it is written average velocity, so what will write? Total displacement upon total time. What is the total displacement? See, starting from here and again on x-axis, means total displacement is 0. Why? It started from house and returned to the same house. So total displacement is 0, total time 3r, 0 upon 3, average velocity will be 0. Okay, so solve the other question and inform me if you're facing any problem. Here I'm ending this session. In the next lecture we will discuss about the velocity time graph and something more. Till then, be safe, take care.